out there then. So this implies then that the 15, and then we're going to need to square m as well, so m squared times 15, if we expand that, we'd have 15 m squared times y to the power of 4 times x squared. So this term here must make up, the 240. Okay, so I've made that statement, 15 times m squared equals 240, m squared therefore equals 16 if you divide by 15, and if you square root a number you get positive and negative version, so n is plus or minus 4. Okay, hence work out the coefficient of the x to the power of 4 and y squared term. Okay, so I've continued my expansion on, although you might jump to the conclusion that you can find a certain symmetry in this, so because you've got the 2 and the 4 and you had the 4 and the 2 before, you'll get the same 15 there as the coefficient. Either way, because we want the y squared x to the power of 4 term, that's going to be this. So we have 15 times by m to the power of 4 will give me the coefficient, because in the other terms are y squared and x to the power of 4 there. Okay, so if m is 4, plus or minus is redundant at this point because anything to the power of 4 is going to be positive. Because it's like you're squaring a squared number, and squared numbers are always positive. So then we're just going to do 15 times 4 to the power of 4. 4 to the power of 4 is 64, and times that by 15. Beg pardon, sorry, 4 to the power of 4 is 256. Got that wrong. Times by 15, and that gives us 3,840. Okay. Okay, another request we've got then was for question 13, so we just want to work out a term which is independent of x. So that's going to be something that doesn't have any x terms in, so it's just going to be a number. Now let's just have a look at a couple of the first terms here just to see, don't try and jump straight to the answer. Sometimes have a little look, see how the expansion develops, think, oh, that's going to cancel with that, this is how I'm going to get the answer that I want. Okay, so we're using Pascal's triangle with the order of 6. Okay, so we did that in the previous question, so we know we've got the 1, 6, 15, 20, 15 to at least get ourselves started. There we go. So if we did the first term then, we'd have 1 times, let's say this is our lead term, so x to the power of 6 times 2 over x to the power of 0, which is just 1, so that's just going to be x to the power of 6. Let's see what happens in the next terms though. So now we're going to have 6 times x to the power of 5 times 2 over x to the power of 1. Okay, now if you simplify that, you don't know what 6 times, and then there's a 2 there, so we get 12. Then you get x to the power of 5, and then if you thought this as a fraction, divided by x, so we're now down to x to the power of 4. I've lost my pen for some reason. It's back. Okay, so we can see that as this one is expanded with this term, they cancel. Okay, so if they're going to cancel entirely, they need to be the same fraction, so the same index number. And given that the index numbers here have to always add up, it's going to be the 3 and 3 one. Okay, so we'll write out the 4 one anyway, so that's the 15 times x to the power of 4 times 2 over x squared. And we can see that we get x squared next to the 4, so we'll be down to the x squared term in our expansion. But here's the one we're interested in, 20 times x to the power of x to the power of 3 times 2 over x cubed. Okay, so we tidy up the numbers, we get 20 times 2 cubed, which is 8, so 20 times 8 is 1,600, and then we get x cubed, but then times by over x cubed. So the x cubes, if you got rid of the brackets there, would cancel, and you'd just be left with that numerical term there, so that's the number that's independent of x. Okay. Now, Amelie asked if we could do something similar to question 9. This one is very similar to 9. So I'm going to just change this question, so I'm going to deviate ever so slightly. You know, what would you have if you had something like 3x here plus 2x to the power of 6? So everywhere where you had x previously, you would just pop a bracket in and replace it with 3x. So we have 1 times 3x to the power of 6 times 2 over x to the power of 0 plus 6 times 3x to the power of I said 6, but I wrote 3 there, didn't I? 5 times 2 over x to the power of 1. And all you do in each of these cases, when you've replaced your values in, you've got your brackets in, your powers add up to 6, and you've got your coefficient in from Pascal's triangle, you just expand it and you simplify it. Okay? So in this one, it's 6 times, so then if we have 3 to the power of 5, which is 243, times x to the power of 5, so that's just that bit all sorted out, times by 2 times, or 2 to the power of 1, so that's just 2 anyway, over x. But really it's all multiplication and division, so realistically I could just write this, the whole thing over x. Doesn't really make a difference. It's like I could have put the first bit over 1 and then multiply the numerators together and denominators. So anyway, what's going to happen now? Well, the x to the power of 5 is going to cancel and go down to a 4 and cancel with that x at the bottom. And then all that's left to do is for me just to do the 6 times the 243 times 2, which my calculator tells me is 2,916. So that would be 2,916 x to the power of 4. Okay, so it doesn't really matter what's in there, just keep your brackets nice and tidy, multiply out numbers and numerators and denominators, etc., and then simplify the terms as you go. Okay. Okay, then the final request was for question 14, and by the way, all these requests are really legitimate requests. These are definitely the trickiest questions, and you'd certainly see something like this at A-level maths in the future, so if you're getting your head around it now, or even getting close to it, you're doing a really good job. So again, my recommendation would be, see what is happening in this sequence, and then as soon as you spot it, jump forward to your conclusion, okay? So if I was to expand this, now we're looking for the x squared term, and we've seen in previous examples with the fractions that we'll get some cancellation, and let's find out and think about when that's going to happen. So they've given us the coefficients, so we're going to have x to the power of 10 as our first time, times 1, times 1, I'm just going to keep, you don't have to do this, times 1, you've got to be careful here, minus 2 over x to the power of 0, which is still 1 though, that's fine, plus 10 times x to the power of 9 times by minus 2 over x to the power of 1. So you can see in this term, just as a side really, regardless of where the answer is going, this minus 2 is going to be pulled out, so this whole term is going to become negative, so it would be negative 20 times x to the power of 8 when that x cancels with that x to the power of 9 term there. So we want to find the x squared term, okay? So when's that going to happen? Well, here, if I simplified this, so this would be x to the power of 10 with the 1 in front of it. This would be, just so we're not going to worry about coefficients, just powers, x to 9 divided by x, that's my x to the power of 8 term. So you can see then the next one, they're going down in 2's, I'd be matching an x to the power of 8 with a minus 2 over, that's a bit there, squared, so then that would be x squared, so that will give me x to the power of 6 term, okay, because the x to the power of 8 would cancel with the x squared term here. And I want to keep going until I get x squared, so to get x squared I'm going to need the x to the power of 6 term, then cancelling, so we've skipped one here, with the, we'd have to have minus 2 over x to the power of 4, so you get x to the power of 6 times by, and then the x to the power of 4 term would cancel with it to get us down to the x squared term. So now all we need to do is figure out what numbers went along with that. So again, if you're not sure about the pattern, you can go back, let's see what we've got here. So we've got x to the power of 10, to the power of 9, let's cross these off up here. To the power of 8 would have 45, to the power of 7 would have 120, so to the power of 6 would have 210. So the number in front of this one would have been 210 times by x to the power of 6 times by negative 2 over x to the power of 4. So tidying all this up, so we're just interested in that term, that's going to be x to the power of 6 divided by x to the power of 4, which is x squared, that's what we're looking for. So the coefficient is going to be 210 multiplied by minus 2 to the power of 4, so that's going to become positive 16, so it's 210 times 16. I'm going to my